Back with day 59, lesson 6.4, our second day on functions and formulas. Today's 3-minute review goal is basically a question pretty much straight out of yesterday's homework, so it should be no big whoop. Use formulas to solve problems involving polynomial functions, and we have a very techie type, technology type formula here. Power in an electrical circuit is given by that formula. P is the power in watts, I is the current, and R is the resistance in ohms. So we're asked to determine the resistance, that's R, determine R when these other things happen. So I'm going to copy down the formula, list my knowns. P was 1,000, I is 12, and so R must be unknown. That's what we're going to solve for. So I'm going to solve for R here. If I want to get R alone, I got to get rid of the I squared, so I'm going to divide by I squared. Divide by I squared. That gives me a new formula, P over I squared, and then I can substitute into that, right? R is 1,000 divided by 12 squared. And I get about 6.94, what's the units? Ohms. Ohms is this little symbol, right? There. That's the resistance. Did you use the substitute and solve method or the solve and substitute? Well, I don't know what you did, but no, I know what I did. What did I do? I rearranged first, right? I solved, then I substitute. Do I care? I don't care which one you use unless you're asked to do one and do the other. So in a question like this, it didn't say. You could proceed in whichever way that you feel more comfortable. You could have put all the values in first and then solved, or do like I did and I rearranged first, right? Rearranged first. All right, on with day 2, formulas and functions and formulas, day 2. What are we asked to do today? Solve problems involving formulas drawn from real-world application. Well, that one's the same as yesterday. Make connections between formulas and linear, quadratic, and exponential functions. Well, certainly, lately we've been dealing with polynomial, right? Polynomial functions. So this is a kind of a connection to review stuff from chapters gone by. It says usually when working with formulas, as in the 3-minute review, we know all of the values except for one. When we use our equation solving skills to find the value of the remaining unknown. So that's what happened here, right? In this formula, there was a bunch of stuff going on. We were given all the information except for one thing. So when we substituted in, there was only one thing left to find, and then we solved it. It was like an equation, right? I solved it and I find the right answer. Notice, in contrast to that, if we leave 2 of the variables as unknowns, we end up with a function, an independent variable and a dependent variable. And that's what we've been dealing with all this semester. Dog's barking. I wonder if someone's at the door. Nope, no one was at the door. The dog's just insane. Back to the lesson. In that formula, if R equals 20 ohms, describe the relationship between P and I. So you see, there's 3 variables, but I'm setting one to be constant. Well, what's the rest that's left over? If R is 20, well, for one thing, this just looks stupid this way. Let's write it with the number part out front. What type of function do I have left over? Well, I'm not used to seeing the dependent and independent variables like this, am I? I'm used to seeing them as x's and y's. This is the independent, and this is the dependent. Well, I'm used to seeing that as the dependent and that as the independent. Now this looks familiar, right? This looks like a polynomial function. This is a quadratic, isn't it? This is a quadratic or degree 2 polynomial. And I could even do a decent sketch of that if I wanted to. I don't have to, though. Note. if I was known, then we would have ended up with a blank relationship between the independent and the dependent variable. So hang on, and I don't know what I would be, but let's just think about it over here in the margin. So let's say that had some value. So this was some number, not a letter. This is some number. And then I could square it, right? Well, then that would become a whole number. So I'd have P equals some number. Let's just say it's 25 for no particular reason. And then R. Well, what would I have left over? Well, the new dependent variable is P. The independent variable would be R. And what type of function is that? Well, it's a linear relationship, right? There's no squared on it. Linear relationship between the independent variable. The independent variable would be R, and the dependent variable would be P. Right? The input variable would be R, and the output variable would be P. Lovely. Let's keep going here. Let's look at the compound interest formula and a typical problem from grade 11. So this is a typical problem from grade 11. Ferd invests $100 for 5 years, compounded annually. He ends up with $175. What interest did he earn? So I'm going to write it down. And remember, anytime that, let's just see what we're given and what we need to find here. A is the amount at the end. He ends up with, that's 175. He invests, the P is the principal, is $100. And often in these formulas, we don't really care, but this is review of grade 11, so why not? This is the principal, or the amount at start, principal, which is the amount at start. I is the interest rate, and it's actually, that's what interest rate did he earn? That's what we want to find. Notice this is per period. So this is per year in this case, so that doesn't really matter. N is the number of interest periods, which is 5 years. I don't have to divide by anything or multiply by anything because it's annually. N is the number of interest periods. And again, if I wanted to, what I could do is I could rearrange this for the unknown, but I'm just going to substitute and solve this time. Why not? Notice I've got only one thing that's unknown. So this is an equation, right? I substitute in for all the stuff I know, and then I've got one unknown that's left over. This is an equation to solve. It's not a function. This one's an equation. This is just like in grade 11. So let's solve it. I is what I need to solve for. I want to get rid of the 100, want to get rid of the 5, get rid of the 100 first. The opposite operation of multiplying by 100 is dividing by 100. We were solving equations like this not too long ago. What's the operation, the opposite operation of exponent 5? Well, it's exponent 1/5, or the 5th root, whichever way you prefer. Like if you prefer to write that as 1.75 to the exponent 1/5, you sure could do that. And then finally, and I could get a number there if I like. I could actually jam that into a calculator. I'm going to do all this in one step because I know then the last little step is to subtract 1 from both sides, and I get I equals the 5th root of 1.75 subtract 1 is about 0.118, some decimal. Well, does that make sense as far as an interest rate is concerned? Well, this is as a percent, right? Ferd earned 11.8% interest per year. Now, this was what this formula in this question isn't sort of the point of these. This is just a plain old formula, and we know how to deal with it. We've got these skills. What we're going to be talking about later in the next example is, well, what happens when we leave 2 of these blank? What's left over? What type of function is left over? Here, when we substituted for everything except for one thing, we ended up with an equation that we can solve. And in fact, in this one, now that we know logarithms, we can solve for any of the unknowns. But what happens when we leave two unknown? We end up with a function. And that's what the next example is all about. And that's what I'm going to pick up in part 2.